So when it came to navigating across the Atlantic in 1620, how did the Mayflower do it? How did the crew know where they were going? Well, let's take a look at some of the instruments that may have been available to them. As of today, positioning is important, and it was no different back in the 1600s, but one of the biggest things for location would be longitude and latitude. The longitude are actually the lines, the imaginary lines that go through the globe that go from north to south, and they're broken into degrees. The equator line is 0. The latitude are the lines, the imaginary lines that go cross-section or cut the globe into slices. Again, the equator is 0, and north, the absolute north and absolute south are 90 degrees. Mariners first learned the skill of navigating by a process known as dead reckoning. To estimate their position at sea by dead reckoning, mariners must first have some idea of their speed, time lapsed at that speed, and their direction of travel. When the Mayflower made her voyage, mariners would have sailed from a port with a known latitude. But at this time, longitude was more difficult for them to calculate and was done by means of dead reckoning. From that point, mariners had to constantly estimate their speed, time, and direction to determine their current location. However, for a vessel that had been at sea for months at a time, the potential for cumulative error was great when dead reckoning was used. So how did they calculate the longitude and latitude? They would do something called running down the latitude. This involves sailing well to either the east or west of their destination until its latitude was reached, whereupon they would sail west or east depending on which side they were on by compass, while maintaining the same latitude. This could be measured quite well from the sun or pole star, until the destination came into sight. This practice was used for many Atlantic crossings in the 16th and 17th centuries, but estimates of longitude at sea still continued to rely on dead reckoning until the late 18th century. Before the sextant was invented, a less precise instrument known as a cross-staff was widely used in the 14th and 15th centuries by astronomers and navigators to calculate the latitude. Also called a Jacob staff, it comprised a wooden main staff with a perpendicular crosspiece attached to its middle. Using a cross staff, it was possible to measure the elevation angle of the noonday sun above the horizon, allowing a mariner to estimate its latitude. The user held the end of the staff to his eye and then slid 2 pieces to measure where the observed objects were in the sky. The location of the pieces and the graduated scale was then used to find the latitude. Sometimes called the slide rule of the Middle Ages or early analog computer, the Astrolabe was an important development in navigational instruments. Invented by the ancient Greeks for astronomy, it was later developed and refined in the Arab world. By measuring the position of the sun or the North Star, and hence the time of day, sailors could determine latitude. An astrolabe came with 2 basic parts: a brass or wooden disc inscribed with 4 90-degree segments around its circumference, at an alidade, or a sighting arm, used to measure angles of a celestial object during a day. Calculations would be based on the altitude of the sun. At night, the altitude of a visible star could be noted. The astrolabe was often used by a pair of mariners, one to sight and one nearby to steady the device and take the reading. When the astrolabe was suspended vertically in a suspension ring, the astrolabe could be rotated and the sun and the stars sighted along its length, so that its altitude in degrees could be read or taken. This would be taken from the gradual edge. The latitude was then calculated by referring to tables compiled by astronomers. Sailors used the astrolabe to determine latitude by measuring the position of the sun or the North Star. Another device of finding latitude was the quadrant. It could also be used to calculate longitude and the time of day. A number of variations on the quadrant were developed, including octants and sextants, which gradually became more sophisticated with the addition of sun filters, mirrors, and sliding scales, graduated in degrees. At the time of the Mayflower's voyage, few charts of any value existed, especially ones that showed the waters of the West and North Atlantic. Christopher Jones was an experienced mariner and navigator, and would almost certainly have a nautical chart map with him. It is known that he consulted maps of Cape Cod, the coastline, drawn by Samuel de Champlain in 1608 and John Smith in 1614. And let's not forget the compass. The navigational instrument described above relied on the sun or the stars being visible to be of use. But when the weather was bad or it was dark, mariners depended instead on a magnetic compass to show their direction. It is known that the Chinese were using the magnetic compass as early as the 3rd century BC, but it is not until the late 12th century that the device first appeared in Europe. By the 15th century, it was common use by mariners. Compasses of the 15th and 16th century did not have degrees marked on them like modern-day examples. Instead, they displayed the 32 equally spaced points of direction known as the compass rose. These were usually marked on a compass face graduations 11.25 degrees apart, indicating north, north by east, north by northeast, etc. In the age of discovery, the magnetic compass was usually made up of a magnetized metal needle attached to a compass rose by a brass pin so that the needle would swing freely and align itself with the magnetic field. It was then kept inside a wooden box to protect it from damage, and the elements suspended within a brass bowl by 3 gimbals. That established the compass to remain fixed in an inertial space when compensating for changes in the ship's yaw, pitch, roll during travel. An important component of the compass was a piece of magnetic iron. The iron ore, lodestone, used to rub along the length of the needle to remagnetize as it needed. The hourglass was another important instrument. The hourglass was the most common way of calculating time at sea. It consists of 2 glass bulbs set on a wooden frame, placed on top of each other and then connected by a narrow tube. The upper bulb is filled with sand, which flows through the tube into the bottom at a given rate. Once the sand is filled, the bottom turned over and time started again. An hourglass usually suspended from the deck head by a length of rope to reduce the effects of the ship's motion on its function. Another instrument would be the Travis board. The Travis board helped the watchkeepers maintain a record of the direction and speed of their ship. Developed expressly for maritime exploration, the Travis board was an aid memoir used in dead reckoning navigation to record the direction a ship was sailing along in, a corresponding speed for the same hour watch speed and travel. Time Travis boards were in use in Northern Europe by the 16th century and would have been used by the crew of the Mayflower. A compass rose with 32 points was fixed to the top of the wooden board, a representative of one of the painted on to the board. From the center of the rose, 8 holes extended out to each 32 compass points. This formed 8 concentric circles and represented 8 by 30 minute time frames, equating to 4 hours of each watch. Each half hour, the direction of the ship was sailing would be measured along a sand glass and a compass, and this was recorded by placing a small wooden peg in a corresponding hole on a Travis board. The first half hour would have a peg put into the hole in the first circle from the center. The second half hour, a total of 1 hour, would have a peg put into the hole in a second circle from the center, and so on. At the bottom of the Travis board, beneath the compass rose, were 4 horizontal rows or holes. These rows were divided between left and right side, and each row represented 30 minutes of time. The holes also lined up vertical columns, representing speed. 1 knots, 2 knots, 3 knots, etc. These worked with the same peg hole method on the compass rows, but instead of recording direction, these rows were used to document the speed. The first row would be used to record the speed at 30 minutes into a watch. The second row would record speed after an hour. The third row was speed after an hour and a half, and so on. After the fourth row, the left side was used. Recording would continue on the top row on the right side after 4 hours. Then the watch was over, the board would be cleared, and recording would start again. So my friends, this is just a few little instruments that they had to navigate back in 1620, because of course they didn't have satellite or anything like that to help them along. So my friends, I hope you enjoyed this quick little video. I hope you find the series informative, and until my next video, happy Thanksgiving, and I'll talk to you soon.